Hello everyone, this video is regarding Lab 6 of EE542 Internet and Cloud Computing. My teammates are Aswathi, Dhrumil and myself Prem Kumar. Here we are implementing a fast reliable file transfer over TCP/IP. The goals of this laboratory is to recognize that packet drop occurs in the network due to a lossy link and not because of congestion. Then the basic thing that we do was we improve the throughput performance by changing the TCP modules of Linux kernel. Exponential backoff is essential part of TCP congestion control, which is implemented using additive increase, multiplicative decrease and linear decrease algorithms. Here in this experiment we remove the exponential backoff and introduce sub-exponential and other algorithms to improve the TCP throughput.
Next is table and graph. To test the file transfer protocol over TCP/IP, we are running the SCP command on Ubuntu operating system without any modification for variable delays and link loss. The delay varies from 10 milliseconds to 200 milliseconds both direction, and the link loss goes from 0% to 10%. As we can see from the graph, the throughput is decreasing drastically on a lossy link. So when we tested the same for 20%, 30% and 50% loss rate, the file transfer process outputs were unsuccessful. Therefore, we need to modify the algorithm, the TCP algorithm in Linux to get a better throughput. Now, for improving the throughput of the network, we need to modify few TCP modules. In this experiment, we have modified 5 TCP modules, which are TCP.h, TCP timer.c, TCP vno.c, TCP output and TCP input.c. In TCP.h, the header file, the retransmission threshold is set to 1. This is done to make sure that the retransmission starts after one duplicate acknowledgement. Then the initial congestion window size is increased to 6250. And lastly, the retransmission timeout is decreased to 41. The next is TCP timer.c. In this, we removed the exponential backoff from retransmit timeout function. Next is TCP vno.c. In this, we increase the congestion window from 1 to 3. And the second thing we did is kept the sender threshold constant. The next is TCP output.c. In this, we remove the multiplicative decrease and linear decrease, and we gave a fixed value to the receiver congestion window. And lastly, the last module for TCP input.c, we remove the multiplicative decrease and also the linear decrease. And also we set the sender congestion window, we gave it a fixed value.
In order to perform our experiment, we need to make certain changes in the Ubuntu operating system. So for that, we need to obtain a local copy of the Ubuntu kernel source code on our machine. So we need to download the source code from the Git repository. So the command goes by so this is for the kernel, and we get it from the site of ubuntu.com. Specifies the operating system as the Ubuntu. And the version of Ubuntu Trusty. So it will take a certain while to get to download the Ubuntu Trusty source code from the repository. After that is done, we need to build the source code in order to obtain certain binary header files. So as you can see, the cloning process is completed. The next step is to build the kernel source code on our local machine. This is done in order to retrieve all the required files and header files in which we will make the needed modification to get better throughput. The command for building is the building has been completed, and the uname minus r is used for obtaining the Linux image. Over here we are getting the Linux image as 4.4.0 31 generic. So this is the Ubuntu on which we will work and do our modifications to test our experiment. After building the kernel and implementing the required modifications in the modules, we need to now compile the entire source code in order to implement the modifications what we have done. So before compiling, we need to make some prior adjustments or pre-requirements. For that, we need the access of the root. So fake root has been downloaded. Now we need to exit the root and then go to our directory. Okay, so after this we need to clean the prior Ubuntu kernel source code and then rebuild it. So the cleaning process is going on. After this we'll compile, and the compilation takes a lot of time, like around 2.5 hours. But that is the most important process, because if the compilation has been done properly, all your header files and other required binary files will be created properly in order to implement the experiment. So the cleaning process has been done. Now we need to run the command for compiling the code. The binary header is for header files, binary generic is for the generic version what we are using. So the process for compiling has started, and we need to wait at least 2.5 hours until the entire compilation process completes. After that, we can carry on with the further process. After modifying all the required modules and recompiling the entire kernel source code, the binary header.deb files are created. We can view them with this command. So these are the 6 binary header.deb files, and these are the required binary header.deb files which needs to be transferred or copied to our node assigned for the experiment using the scp command. This is done in order for further testing. So the command goes as follows. So this is the server where we need to transfer it or copy it, and on that we need to do it on a particular folder which goes as users usc542bn tmp, the inbuilt temporary folder, and the temp what we created. So now it is, so now we need to enter the password. So as you can see, the scp process is going on and the header files are getting transferred. It is already done. The header files has been transferred to the node. So now the further step is to access the node and then do the further testing part. We are going to access the nodes in order to do the further testing. So we are going to do that using the ssh command. For the second one, now we need to go into the particular nodes, that is node A and node B. Okay, so now we are into the nodes node A and B. So the further step is to, now we need to unpack the files what we transfer from our local machine. So here we have the files. So now the command for unpacking the files, the binary header.deb files, and executing the Linux source code, the modified Linux source code on our nodes is as follows. Simultaneously, we'll do on the other node as well. So the process for unpacking the binary header files is going on simultaneously on both the nodes. Once that is done, we need to reboot in order to implement the Linux operating system on the nodes. So the unpacking of the header files has been completed on node A. Now let's reboot. Okay. So once you enter the command for reboot, the connection to the node gets closed, and then you need to re-log in order to implement that Ubuntu modified Ubuntu. So as you can see, we have successfully transferred the files, unpacked it, and have implemented the command for rebooting, and, as we can see, the connection of both the nodes has been closed, saying that once you re-enter or do SSH again onto these nodes, the new Ubuntu system will be running, and we can then test our experiment.
Now that the rebooting is done, we again SSH into our nodes. Now we are into our nodes. Now let us go to temp folder. Here also the same thing. Now here I run few system calls which have to be implemented. The first thing is to the first thing that we do is we select congestion control as we know, because here we are dealing with wireless networks or satellite networks which has lots of losses involved in it. Then the next command is the TCP window scaling, which is given as 1, which is basically a multiplicative factor. Then the next three commands are used to set the window size of congestion control, sender and receiver to 5242880. Now that all the system calls have been implemented, I create a file of 1 GB. So this will take some time. See, the 1 GB file is now generated. So I do SCP. So this is the throughput that we are initially getting, and it will take some time to transfer the file. Now once when the ACP has completed, we see that the throughput that was obtained is 1.2 megabytes per second, and then when we calculate it, we get 10.06 megabits per second. So this is how we have made changes with the TCP module of Linux kernel, and we are getting the throughput of 10.06 megabytes per second. And thank you for watching this video.